Hello. We're going to talk about how we bend the cost curve downward. And I'm glad that cost is on top of all of your mind, and how we are going to increase the operational efficiencies. I'm going to walk you through a journey of how SurveyMonkey increased the Snowflake workloads by close to 5x with a marginal increase in Snowflake credit consumption. I'm Subramanian. I'm head of engineering and data platform at SurveyMonkey, where I lead an amazing team that supports the end-to-end data platform and data pipelines at scale in order to power the enterprise analytics. What we have on the deck today, I'll give you a brief overview of who we are and what our SurveyMonkey data landscape entails, and what our Finops framework looks like for Snowflake. And then we'll walk you through all the optimizations that we have done over the past 3-4 years. And so I'll give a brief overview of the tools that we use for visibility and troubleshooting, and what our future expansion plan in Snowflake is going to look like. And I'll summarize all the learnings at the end. Let's talk about SurveyMonkey. SurveyMonkey is a leader in online surveys and forms. We power the insights needed for decision making at scale. With over 25 years of experience, SurveyMonkey has helped organizations across all industries and sizes to help measure their, how satisfied their customers are, and also the feedback on the product, and how engaged and happy their employees are. What this also means is we collect and process a lot of data, as you can imagine. Also, let's double click on what are the use cases that you can use SurveyMonkey for. Whether you want to gain for customer feedback, employee feedback, and market research is one of our widely used use cases. And you can help, this can help delight customers, create product advocates, and you're increasing the competitive advantage in the marketplace. A small plug there, try your product and you'll be delighted by the level of insights and ease of decision making. So this is our SurveyMonkey data landscape, end to end. You can see that Snowflake is our center of this ecosystem. I call it the central nervous system of our enterprise data analytics platform. We bring in data from more than 25 different data sources, whether it is structured, semi-structured, or streaming pipelines. And we also have several SaaS applications like Salesforce, Gainsight, Salesforce Marketing Cloud, from which we bring in the data into Snowflake. The types of data that we bring into Snowflake includes product usage data from our transaction systems, clickstream log data from our different web application logs, and then CRM data from Salesforce, and we bring in a lot of marketing campaign information and marketing operations data as well. We utilize Snowflake as a data lake and a data warehouse, which means you have the raw data and the process data. And if you want to combine those for predictive analytics as well as descriptive analytics, you can do so. We have a lot of dashboards that are powered by the process data. And it's easily possible to do it without having to connect to all the external tables. We have a centralized, unified data model. One of my colleagues, Samiksha, talked about our foundational data model using SQL DBM a couple of days ago. This data model is data product agnostic. It can power all the data products with one centralized unified data model. We build data marts for all the individual business functions with the key performance indicators to power those business functions. At the end of the day, it's all about enabling the business. We produce scorecards to measure organizational health and the individual business functions' health. And we run several predictive models for churn, expansion, cross-sell, and upsell. And we're always looking for opportunities to increase revenue and retention for the organization through data. We have more than 30 million queries per month that are run in our Snowflake system. We have more than 200 plus users that go to Snowflake and ask questions and get the answers through data. And we have more than 5,500 tables and 600 plus views. That just shows the overall full broad landscape of our Snowflake ecosystem. We use some features like secure data sharing. We bring in data from HubSpot through secure data share. We follow all data governance practices when it comes to usage of the dashboards or the ownership of the metrics. And we use dynamic data masking, which is a Snowflake feature that upon consumption, you can mask the data for all the personal data information. We have more than 180 plus workflows that power this entire end-to-end data platform. Snowflake Finops. What does a Finops framework look like? It contains 3 pillars, essentially. First one is visibility. So we have the visibility into our spend. For example, we know that our daily core ETL process takes most of our spend for compute in Snowflake. And then we then focus on limiting and controlling the spend. Once you have the visibility, then you look at, okay, what are the budgets and guardrails required for the individual warehouse level or at the account level. And then our forecast variance has been less than or equal to 10%, which is brilliant when it comes to how we are forecasting how much money we are going to spend versus the actuals. And then once you have the visibility and you're having good control, then you look at optimization. What are all those opportunities that exist for us to optimize and keep the business running? And this framework is iterative. It's not a one-time done. It's iterative. You got to do it over a period of time and consistently. Okay, if you look at this chart, this is pretty interesting. Our Snowflake spend has been pretty consistent since 2021 all the way until Q2 2023, actually Q1 2023. And then in the last 4 quarters, you see a huge spike in our workloads, which I'll talk about as to why. And most of the spend is attributed to the compute. Needless to say, that's the typically, you spend less on storage, you spend more on compute in Snowflake. Now, this is not the whole story. I'm not here to just talk about that, hey, I'm spending more money with Snowflake, right? We are going to talk about the story of how we operated at scale. This is our usage overview since the beginning of time. So before I dive into this chart, I want to give you a background of our Snowflake journey. Back in April 2021, we migrated to Snowflake. We were running a 15-year-old SQL Server data warehouse on-prem prior to that. Since April 2021, the number of tables in Snowflake has increased 5x. And if you look at our cost, it has marginally increased by 27%. And we are able to do all of this without any disruption to business. That's the critical part. On this chart, the x-axis shows the timeline. The left vertical axis shows the number of queries or workloads in millions, and the right axis shows the number of Snowflake credits we spend per 10,000 jobs. You can see the economies of scale here. Back in Q1 2022, we spent approximately 14 credits per 10,000 jobs. As we scale, workloads are increasing. Now we are spending only 4 credits per 10,000 jobs. This is what I'm going to talk about as to how did we get there. We'll deep dive into what our optimization journey has looked like. So as I mentioned before, back in Q2 2021, we migrated 100% of our workloads to Snowflake. The first thing we looked at was, okay, what are the batch jobs that are running and what are the interdependencies between those jobs? And then we are looking at a few long-running jobs and thinking which of those can we execute in parallel. So the massive amount of parallelism of the Snowflake compute really came for help. We also diverted certain ingestion workloads to its own cluster in order to use the power of parallelism. Okay, then the next step in the journey is, okay, what are those long-running jobs that we can potentially optimize? So we found out that a few update queries were taking longer because when we migrated from SQL Server data warehouse to Snowflake, the way the query engines and the query plans work are different. How they are interpreted are different. So we had to go and optimize our Snowflake queries to be more optimized, right? By the way, we do not hire any engineers that write bad joins in SurveyMonkey. The reason we had to still do this optimization was because of the interpretation, and when we did the Snowflake migration, we were on a tight timeline, but we knew that we had to do a fast follow after the migration in order to go and optimize these queries. And we made things simple. Some of the complex SQL store procedures we are able to simplify. And you can start seeing that the curve is already bending, right? This is, I'm talking as soon as we migrated to Snowflake. The next thing that we did was right sizing of the different warehouses. We looked at the usage metrics across every warehouse, what types of workloads run on them, how long it's taking, and what are the sizes of the individual warehouses. Are they right sized to the right workloads? And we were able to realign the jobs to the right clusters accordingly. And we are able to also resize the cluster. If I don't need to over-provision, I did not over-provision. If I don't need to under-provision, I'm not under-provisioning. So that's an effort we looked at across all the individual warehouses. And we assign warehouses to the individual business functions as well. If someone is in finance, and finance wants to run a query, finance got their own compute cluster in Snowflake, so that in future, if you want to pass along the cost to them, we could. Same thing with sales, same thing with marketing. Next, we wanted to utilize the power of Snowflake warehouse caching. We looked at the commonly accessed tables and views, what are those query patterns, and we create the intermediate tables in order to fully utilize the caching power of Snowflake. This was brilliant. We started seeing a steep curve in our Snowflake cost consumption. Because if you utilize the same warehouse for this, for the intermediate tables that you're going to reuse again and again, you get maximum benefit out of the caching mechanism. Then back in Q3 2022, Snowflake did something behind the scenes that we are still thankful to them. They migrated their AWS EC2 instances to Graviton processor. So Graviton processor is an AWS processor that is environment friendly with high horsepower. This happened behind the scenes. We as a customer did not know that it happened. However, this helped in our Snowflake cost consumption going down. We got more scale out of Snowflake. Let's double click into that. So this chart shows the average daily activity 1 week prior to the Graviton migration and 1 week post the Graviton migration. You can see that post the Graviton migration, the number of the credit consumption decreased by 8.6%, while the number of workloads increased by 7.1%, and the number of credits per 10,000 jobs decreased by 13.9%. Now, this is showing only 1 week post migration. However, what we have seen over the last 2 years since we migrated, on an average, probably we have gained efficiency of 8 to 10%. Now, this is something we did back in Q2 2023. We have our product usage data and the billing transaction data, all these coming from our production transaction database. It is running in SQL Server. Now, this is different than the SQL Server data warehouse that I mentioned earlier. Not all tables were incremental loads. So we had some huge tables that had full loads because there was no change data capture strategy. What I mean by change data capture is we want to bring in only the data since the last load that has changed, whether it was inserted, updated, or deleted. So we worked with our upstream partners in the production transactions DBAs and to implement a change data capture solution using HVR. This had a big impact in our ingestion workload timings. It brought it down by almost 80%, and which also resulted in cost savings in Snowflake. You can see the curve is still going down. Now it's kind of starting to be consistent. One thing I want to point out here is why did we have a huge spike in workloads in the last 3 to 4 quarters? We have some big initiatives like data-driven enablement, and a huge marketing initiative that was going on in the organization. It's still going on. And this also meant that we had to bring in data from 15 additional data sources. And we had to literally have a new version of each of the KPIs that we're measuring in the organization to gauge all the health of the different business functions and at the organization level as well. So that's why you see a huge spike in workloads. However, we did not disrupt it. With all the optimizations we are done, we were ready. We are just saying, bring it on, no problem, right? Then back in Q2 2023, we have another transaction database which is residing in MySQL. So we have some website experiments and application experiments data sitting in there. We did not have a out-of-the-box change data capture solution for that. So what we did was we had to be creative and implemented our own change data capture solution. Once the data landed in S3, before it landed in Snowflake, we did some magic to bring in only the incremental loads. This again decreased the load timings by 50% and hence direct impact on the cost. Prior to that, it was a combination of full loads for certain tables and delta loads for other tables. By delta, I mean any changes since the last full load. Now, things didn't stop. We had to, because we are doing this big initiative, more workloads are coming in and hitting Snowflake. We wanted to continue the journey of how we can use the intermediate tables and views efficiently so that we can maximize the caching again. This was particularly important for certain initiatives, like we are rewriting our data model to be more scalable. And we are building more on our Customer 360 data product. So we are finding opportunities to have more intermediate tables that I can utilize across the workloads and make it faster. So we use dbt for our business logic transformation layer. So once the data lands in Snowflake, we process it in dbt, apply all the business logic transformation. dbt really helped us in terms of applying software engineering best practices to data engineering. And when we procured dbt almost 2 years ago, we had only a few data models to run, few tables to load. As we scaled today, when you saw all those big spikes in workloads, we are running several hundred data models. So how do we scale? We used to run the continuous integration and continuous deployment jobs every single day. We used to bring the latest into the UAT and production environment and run the CI and the CD jobs. This was fine initially when we had a few models. As the workloads grew, this did not scale. This used to take several hours to run. Originally, this was deemed as a best practice. Talking to dbt folks, we thought this is a best practice. It makes sense. Bring in, run these jobs continuously in the lower environment, so we have a high degree of confidence. Now we had to challenge that. So what we did was we stopped the daily jobs. Instead, we looked at running the jobs whenever a pull request is created. Pull request, I mean a change request of the code is created in GitHub. That's when these jobs were triggered. Now, every CI and the CD job is now part of the PR creation, and any changes since the latest production successful run of the CI, only those were run in the UAT and the pre-prod environment. We use pre-prod for continuous deployment jobs so that there's a high degree of confidence before the code goes to production. We run the CA jobs against the UAT environment so that it can look at all the upstream and the downstream dependencies and rebuild all those models. Models, for all practical purposes, think about it as data load into tables. That's the easiest way I can explain it. Now, our most recent optimization is we deprecated a few data products and related data pipelines. It's always a good question to ask. Those dashboards that we created 2 years ago, 3 years ago, are they still valid? Are they still being used? Are the metrics still valid? When was the last time someone looked at those numbers? These are some good questions to ask. I can guarantee some of you will see that, hey man, no one has used this dashboard for like 2 years. You will actually see that. So this is a question that we continuously ask. particularly with new dashboards being created that has similar metrics to whatever we created 2 years ago. Why still support them? I call this hygiene, just like you go for dental hygiene check once a year. I'm thinking of a quarterly hygiene check against your Snowflake. How does it help? And we are able to consolidate and make the pipelines more efficient. Next, I want to briefly cover about all the tools that we use for visibility and troubleshooting. The native Snowflake cost management and budgeting controls are extremely critical for us. We have budget control set for at the monthly level. So we know when we are above the threshold, we know that it's time to look at it and take action if it's beyond 110% or 120%. We have resource monitors for alerting at the individual warehouse level, also at the account level, so we know exactly by day, so that these alerts we receive every day. We have a threshold of X number of credits per day, so I know that, okay, that's my sweet spot. And then Snowflake warehouse activity, so this tells us whether there is excessive queuing, are there blockers with the queries, is the warehouse sized properly? So we use the warehouse activity from Snowflake. And then we use a tool called Monte Carlo. We use this for data observability. And recently they introduced this performance monitor feature. It gives a good one-stop shop of visualizing where the bottlenecks of queries are and what are those downstream queries that are waiting on these queries that are running for a long time. It's just an easy to visualize tool for that, for the performance monitor feature. And then we use the data lineage feature of Monte Carlo, which tells us, okay, if I'm deprecating a specific dashboard, what are all the upstream tables that are going to be impacted? What are all the upstream pipelines that I need to go deprecate? So we are able to connect the dots using that lineage feature. It tells us that from the time the data lands in Snowflake all the way through to the consumption layer, what are all those dots that are connected? And then we look at the Snowflake query history as well to look at the overall activity within Snowflake that's happening over a period of time. Okay, now that we got all the dividends from all the optimizations that we have done, it gives us all the cushion to go innovate, find out what other features that we can utilize in Snowflake for our use cases. So right now we are looking at Snowpark for our log data ingestion use case. It used to run in AWS, EMR, and Spark. Can we actually bring in all of those into Snowflake so that we have only one ecosystem to support and not worry about supporting Spark and EMR and supporting Snowflake? As we are going the self-service journey, wherein we want to get the data into the hands of our stakeholders quicker, faster, and make it easier for them, we are looking at Snowflake Copilot. And also, some of you have heard about Cortex Analyst. We're also looking at that to make it easier for even non-technical stakeholders to be able to get data within Snowflake. We're also going to explore the Snowflake Apache Iceberg tables for another set of log data ingestion to get it in open Apache Iceberg format. There are two use cases for Snowflake Cortex we are looking at. One is time series forecasting for our customer operations use case, and text summarization for some product analytics use cases. And Streamlit, we are looking at, can utilize for interactive dashboards, wherein someone can say, hey, I need to change the threshold on the fly as you compare to the actuals. Can they actually plug it into the Streamlit dashboard? Okay, let me quickly summarize what are some of the takeaways from this session that you can put to use. Cultivating a FinOps mindset. This is a cultural aspect, because understand this, you care about Snowflake costs a lot more than your stakeholders will. So how do you make it a team effort, right? It's not a one-person effort. 2 weeks ago, one of the marketing stakeholders came to me and said, hey, I was brainstorming this one particular use case with your engineers, and the engineer was saying that, hey, let's go with option 2 because it'll save us less money, cost us less money in Snowflake. That is brilliant. That is like every engineer and analyst are thinking along the same lines. That's the cultural mindset of FinOps. Having a pulse of usage across your tech stack. Look at your left side and the right side of Snowflake. What are the tools and technologies I'm utilizing, and are there opportunities to optimize those? Creating best coding practices, playbook, and templates. So people are not writing bad queries. We know in Snowflake there's a certain way to write queries, and which may be differing from other like Oracle or SQL or other tools there. Remember, your next dollar saving could be a low-hanging fruit. Let's say one query is taking 18 minutes to run, and it's running every single day and twice a day for 365 days. All this adds up. And it may also create excessive queuing. So you go optimize that one query to let it run in 30 seconds. The benefit is amazing. It's all about economies of scale. And setting up daily thresholds and monitors, as I mentioned before. Rinse and repeat. This is a quarterly hygiene check. I mentioned about the unused dashboards and unused pipelines. And then this is ongoing. It's not a one-time effort. Just like when you're looking at your bank and your savings, you're always thinking that, okay, how can I save more money? This is exactly that. It's something that we'll have to rinse and repeat. Thank you so much.